All right, welcome back, everybody. So the other phenomenon that we are going to explore today is the pitch of sound and how it can change depending on some interesting circumstances. I already asked you this question as well over in the Get Ready activity, and it turns out that the pitch of sound is related to the frequency of that sound. And either the regular frequency or the angular frequency will work here. So the frequency is the thing that is related to the pitch that you hear. And as you saw in the video, that pitch depends not just on the thing producing the sound, but also on whether there is any relative motion between the thing creating the sound, which we'll typically call the source or the emitter, and the person or the thing that is listening or perceiving the sound. And that difference is something called the Doppler effect. And there's an equation for the Doppler effect. We're not going to take time in this class to derive it. It's got a neat derivation. You can look it up and understand it in a few minutes. But we're only going to try to make use of it. So the way that it works is if you want to know what frequency you're actually going to hear, then what you want to do is take the frequency that the sound is actually produced at, and then multiply it by a fraction that includes a few different possible velocities. The first one is the speed of sound. V sub sound here is just the speed of sound in whatever medium the sound is traveling through. So for sound waves in the atmosphere of Earth, close to the surface of the Earth, the speed of sound tends to be something like 343 meters per second, which is pretty fast. The other two things that you need to know is how fast is the listener moving with respect to the medium, to the air, if it's sound waves, and how fast is the emitter, the thing that's making the sound, moving, again, with respect to the thing that's carrying the sound, so the air. One thing that's really important to note here is that both the listener and the emitter are quantities whose sign matters. It matters whether you say these are positive or negative. They're really velocities and not just speeds. The convention is that both of them with this equation are positive if the relative motion is towards one another. So if the thing that's making the sound is coming at you, or if you are going at the thing that's making the sound, and they're negative if the two things are moving away from each other. And you can also see that there is an innate positive versus negative difference in the numerator versus the denominator. All of those positive or negative signs are critical to correctly utilizing the Doppler.